Welcome to this video on pressure, a key concept in GCSE Physics. From sharp knives to deep-sea dams, we will explore how pressure works, its importance, and how to master the calculations you need for your exams. In this video, we will cover the definition of pressure, its units, and the core formula. We will then examine how force and area influence pressure, look at pressure in liquids and gases, and finally, review some essential exam strategies. Chapter 1. What is pressure? At its core, pressure describes how a force is distributed over a surface. It is a fundamental physics concept that explains why objects like sharp knives cut easily, or why snowshoes prevent you from sinking. Pressure is defined as the force acting per unit area on a surface. The pressure you exert depends on two things: how hard you push, which is the force, and the size of the surface area you are pushing on. Pressure is measured in pascals, named after scientist Blaise Pascal, with the symbol Pa. 1 Pascal is equal to 1 Newton per square meter. A higher value indicates greater pressure, caused by more force, a smaller area, or both. The core formula for pressure is force divided by area. P stands for pressure in pascals, F for force in newtons, and A for area in square meters. Remember that you can rearrange this formula to solve for force or area. To easily rearrange the pressure equation, you can use a formula triangle. Simply cover the quantity you want to find, and the remaining values will show you whether to multiply or divide. Chapter 2. Force and area. There are two simple rules to remember. A larger force creates more pressure, while a smaller area also results in more pressure. Let's look at how this applies in the real world. How does force affect pressure? When area remains constant, increasing the force leads to a proportional increase in pressure. This direct relationship means that if you double the force, you double the pressure. Conversely, how does area affect pressure? With a constant force, reducing the area increases the pressure. This is an inverse relationship, where having the area effectively doubles the pressure, a principle used in everything from snowshoes to tractor tires. Sharp objects like needles and knife blades are designed specifically to generate high pressure. By minimizing the contact area, they concentrate even small amounts of force into a tiny point, allowing them to pierce or cut materials easily. On the other hand, wide objects are designed to reduce pressure. Tractor tires, snowshoes, and tank tracks all increase the contact area to distribute weight, preventing vehicles or people from sinking into soft or uneven surfaces. Let's check our understanding with an example. For a book weighing 12 newtons on an area of 0.04 square meters, we divide the force by the area. This gives a pressure of 300 pascals. Chapter 3. Pressure in liquids. Liquids behave differently than solids. Because their particles are closely packed and move freely, they transmit pressure throughout the fluid in all directions. Liquids create pressure due to their weight. As you go deeper, the weight of the liquid above pushes down, resulting in greater pressure. This is why submarines require strong hulls, and why your ears may pop when diving deep. Pressure in a liquid increases with depth. At the surface, pressure is lowest because very little liquid pushes down. Moving midway down, pressure becomes moderate, and at the bottom, it is at its greatest due to the maximum weight of the liquid above. Unlike solid objects that only exert force downwards, liquid pressure acts in all directions simultaneously. This is because liquid particles move freely and push against any surface they touch, whether above, below, or to the sides. This omnidirectional pressure has several effects. It causes upthrust on submerged objects, creates downward force due to the weight of the liquid, and pushes outward against container walls, which is why those walls must be strong. Liquid density also matters. Denser liquids have more mass per unit volume, creating greater weight and higher pressure at any given depth. For example, salt water exerts more pressure than fresh water, and mercury is used in barometers due to its high density. A classic exam question asks why dams are thicker at the bottom. The answer is that water pressure increases with depth, so the base of the dam must be thicker and stronger to withstand the much higher force compared to the top. To summarize for your exams, always link the base thickness of a dam to the fact that water pressure increases with depth. The structure is reinforced where the pressure is at its maximum. Chapter 4. Pressure in gases. Gas pressure behaves differently than solids or liquids because gas particles are far apart and move rapidly and randomly. Understanding what triggers changes in gas pressure is essential for your physics revision. Gas pressure is caused by particles colliding with the walls of their container. Each collision exerts a tiny force. The more frequently these particles collide and the harder they hit the walls, the higher the overall gas pressure becomes. Heating a gas increases its pressure. When you heat the gas, particles gain kinetic energy, moving faster and colliding with with container walls more frequently and with greater force. This is why aerosol cans or car tires can become dangerous when overheated. At a constant volume, pressure and temperature are directly proportional. When the temperature is low, particles move slowly, resulting in fewer collisions and lower pressure. As temperature rises, faster particles lead to more frequent, forceful collisions and higher pressure. In summary, gas pressure is caused by particle collisions. It acts equally in all directions, increases with temperature or decreased volume, and decreases when the temperature falls or the volume of the container increases. Chapter 5. Pressure in everyday life. Understanding these concepts helps explain many designs, from medical equipment like syringes, to the complex engineering found in submarine hulls and other structures we encounter daily. Sharp objects are designed for high pressure. Kitchen knives, drawing pins, and needles all use very small contact areas. By concentrating force into a tiny point, they create the high pressure needed to cut, pierce, or puncture materials with minimal effort. Conversely, wide surfaces are designed for low pressure. Skis, lorry tires, and even a camel's feet distribute weight over a large area. This reduces the pressure exerted on the surface, preventing the object from sinking into soft ground or snow. Finally, hydraulics rely on liquid pressure to multiply force. Because liquids are incompressible, they transmit pressure efficiently. This principle powers car brakes, garage lifts, and the heavy-duty arms of construction equipment like diggers and cranes. Pressure under the sea is intense. For every 10 meters of depth, water pressure increases by about 1 atmosphere. At the bottom of the Mariana Trench, pressure is over 1,000 times higher than at sea level, necessitating reinforced steel hulls for submarines. Pressure questions are a staple of GCSE Physics exams. To maximize your marks, focus on key principles, avoid common mistakes like incorrect unit conversions, and apply the right strategies to every problem you encounter. Remember these 2 golden rules. First, pressure increases with force when area is constant. Second, pressure increases when area decreases, provided the force stays the same. Understanding these relationships is crucial for solving exam problems. Avoid common pitfalls. Use newtons for force and square meters for area, always converting units if necessary. Remember to rearrange equations before substituting values. Distinguish clearly between force and pressure, and recall that liquid pressure acts in all directions. When answering explain questions, use a 3-step technique. First, state the relationship. Second, apply it to the specific scenario in the question. Third, use precise technical vocabulary like pascals, particle collisions, or density to secure your marks. Key vocabulary includes pressure measured in pascals, force in newtons, and upthrust as the upward force from a liquid. Remember that density is mass per unit volume, and kinetic energy is the energy of motion for gas particles. Let's test your knowledge. Can you calculate pressure given force and area? Can you explain why sharp knives cut better than blunt ones? How does depth affect dam design? Or how does heating a gas increase its internal pressure? For the first question, the pressure is 120 pascals. A sharp knife works by concentrating force on a smaller area. Dams are thicker at the base due to increased water pressure. Heated gas pressure rises because of faster, more frequent particle collisions. We have explored the full picture of pressure, from solids and liquids to gases and practical applications. Mastery of these concepts forms a solid foundation for your physics studies. You are now ready for your exam. Remember the formula P equals force divided by area, keep your units correct, and link your physics knowledge to the exam context. Good luck with your studies.